Hello everyone. Today we are going to start lecture 02 of class 8 mathematics, chapter number 1, which is rational numbers. In this lecture we are going to study about properties of addition of rational numbers. So let us move and start with the first property, which is closure property. Now what does this property say? It simply says that if a upon b and c upon d are two rational numbers, comma, then a upon b plus c upon d is also a rational number. That is, if you add two rational numbers, then you will always get a rational number. So this is the simplest property. Closure property simply states that if you add two rational numbers, you will get a rational number. Now recall that if you add two integers, then also you get an integer. Okay, so this property holds true on integers also, and we have already seen that rational numbers are superset of integers, that is, integers are part of rational numbers. Okay, so this property is true for rational numbers, it is always true for integers. Let us verify them for the rational numbers, right? Let us take an example. 1 upon 4 plus 2 upon 3. Clearly these both are rational numbers because they are written in the form of p upon q, where both numerator and denominator are integers and denominator is not equals to 0. Okay, so let us try and add these two numbers. Now we can see that LCM of 4 and 3 is 12, so we will make them 12. So we have to multiply 4 by 3 in order to make it 12. Similarly, we have to multiply numerator also by 3 so that the fraction remains same. Here we have to multiply 3 by 4 to make it 12, so we have to multiply 2 also by 4 to make it 12. So we will get 3 upon 12 plus 8 upon 12, which is 11 upon 12. Now clearly 11 upon 12 is also a rational number. So what you will write? You will write 11 upon 12, which is a rational number. So you can see we have added two rational numbers and we got a rational number, right? It is true for all rational numbers. Even if you add 0 to 1 by 2, then also you will get 1 by 2. Again, adding 0 is also a rational number. Okay, and half is also a rational number. Similarly, you can verify the result for all rational numbers and you will get the same result. So closure property is one of the simplest properties on addition of rational numbers. Now let us move to the second property, which is commutativity. What does commutativity means? It simply states that if a upon b and c upon d are two rational numbers, comma, then a upon b plus c upon d equals to c upon d plus a upon b. That is, it does not matter in which order you add two rational numbers, they will always give the same result. Now let us verify this property, that is property of commutativity of rational numbers. So let us take first example to be 5 by 6 plus minus 4 upon 9. Now let us add 5 by 6 plus 4 upon 9, and in second example let us add minus 4 upon 9 and 5 by 6. Now these both are same numbers, but we are adding in different orders. That is why I am counting them as two examples, and let us see if we get the same result or not. Now LCM of 9 and 6 is what? 18. So you can take the denominator as 18. Now to multiply 6 by 3, we have to multiply 6 by 3 to get it to 18. So we have to multiply 5 also by 3. So we can write 5 into 3 plus, to multiply minus 4 by 2, we have to write minus 4 into 2. Why? Because 9 into 2 is 18. So we will get 15 minus 8 upon 18, which is 7 upon 18. So we got 7 upon 18 by adding 5 by 6 and minus 4 by 9. Now let us see what do we get in the second example. Again the LCM is 18. Now 9 into 2 is 18. So minus 4 into 2 is equals to minus 8. Similarly 6 into 3 is 18. So 5 into 3 is equals to 15. So we will get minus 8 plus 15 whole upon 18, which would give us 7 upon 18. Right. So this was the property of commutativity. Clearly it simply states that you can add two numbers in any order. It will not affect the result. Right. Let us move to the third property, which is associativity. So what associativity says is that if A upon B, C upon D and E upon F are rational numbers, then if A upon B, C upon D and E upon F are rational numbers, then A upon B plus C upon D plus E upon F, where C upon D and E upon F are added first, is equals to A upon B plus C upon D plus E upon F, where A upon B and C upon D are added first. That is, it does not matter which two numbers you add first, you will always get the same result. On the LHS, we are adding C upon D and E upon F together, and then we are adding the result to A upon B. On the RHS, we are adding A upon B and C upon D together, and then we are adding the result to E upon F. And that is not making any difference because we have an equal sign between both LHS and RHS. Now let us verify this property. Okay, let us verify this property for numerical values. Let us add. Okay, first let us check them for integers so that it becomes easy to understand and what do we mean by associativity. Let me first check it for integers. You all know integers is a part of rational numbers. Okay, so if it is holding true for rational number, it must hold for integers. Let us see. 1 plus 5 plus 8. Let us calculate this. So we will get 5 plus 8 equals to 13 and the result would be 14. Similarly, by applying associativity, let us do this. Let us firstly add 1 and 5 and then add to 8. We will get 6 plus 8, which is equals to 14. So you can see associativity is holding true for integers. Now let us check this property for rational numbers. Let us add minus 3 upon 4 plus 5 upon 6 plus minus 4 upon 9. Now let us add them. So we will get minus 3 upon 4 plus the LCM would be 18. Okay. So 6 into 3 is equals to 18. So 5 into 3 is equals to 15 plus 9 into 2 is equals to 18. So minus 4 into 2 equals to minus 8. Right. So we would get minus 3 by 4 plus 15 minus 8 is equals to 7. So we will get 7 upon 18. Now taking LCM of 4 and 18, we will get 36. Now 4 into 9 is equals to 36. So minus 3 into 9 is equals to minus 27 plus 18 into 2 is equals to 36. So 7 into 2 is equals to 14. So we will get minus 13 upon 36. Right. Now let us check the same property by applying associativity. That is by adding minus 3 by 4 and 5 by 6 first and then adding the result in minus 4 upon 9. So again LCM of 4 and 6 would be 12. So we will get 12. Now 4 into 3 is equals to 12. So minus 3 into 3 is equals to minus 9 plus 6 into 2 is equals to 12. So 5 into 2 equals to 10. So this is what we get after adding minus 3 by 4 plus 5 by 6. And then we have to add the result to minus 4 upon 9. So here we will get 1 upon 12 plus minus 4 upon 9. Again taking LCM of 12 and 9, we will get 36. So 12 into 3 is equals to 36. So 1 into 3 equals to 3 minus 9 into 4 equals to 36. So 4 into 4 is equals to 16. So again we will get minus 13 upon 36. Clearly you can see that both the numbers are same, that is associativity holds true for rational numbers. It is also very easy property, and it can be used to simplify bigger expressions which are involving 4 to 5 terms. You can pair up the terms according to the denominators and you can easily solve it without taking effort, right? So it makes the simplification of questions a bit easier. Now let us move to the next property, which is existence of additive identity. It is also a very simple property, and what it says? It says that sum of any rational number, it says that sum of any rational number and 0 is the rational number itself, right? That is, it is very easy. You all know that if we add 0 to any number, it do not make any change, right? So the rational number is itself. That is, if a upon b is a rational number, let us take a upon b to be a rational number. Let a upon b be a rational number, comma, then a upon b plus 0 is equals to 0. And since commutativity is present, so we can also write it as 0 plus a upon b. So you can add 0 to a upon b and you will still get a upon b. Okay, here you have to write a upon b, right? So a upon b plus 0 is equals to a upon b itself. See, the rational number is coming itself, so 0 is not making any kind of change. Now what is 0 called here? What will be the meaning of additive identity? Now 0 is called additive identity. Let me write it. Here, comma, 0 is called the identity element. 0 is called the identity element or additive identity for the identity element or the additive identity for the addition of rational numbers. So 0 is the identity element or additive identity. So what is additive identity? Any number which when added to a rational number does not make any change. Okay, so 0 is that number for addition, right? So if you add 0 to any rational number, it will not make any change. Similarly, there is also something called existence of additive inverse, which is also called negative of a rational number. So now what is additive inverse, right? Again, if a upon b and c upon d are rational numbers such that these are rational numbers such that a upon b plus c upon d is equals to 0 is equals to c upon d plus a upon b. That is, if after adding two rational numbers we get 0, then both the numbers are said to be additive inverse or negative of each other. So if a upon b and c upon d are rational numbers such that after adding them we are getting 0, then those rational numbers, that is a upon b and c upon d, are called negatives or additive inverse of each other. That is, A upon B is additive inverse of C by D, and C by D is additive inverse of A upon B. So it is pretty clear, right? So how does we write an additive inverse? Let me show it. Additive inverse of A upon B is equals to minus A upon B. So what is additive inverse? It is nothing but minus 1 multiplied by the number. So if you want to calculate additive inverse of 2, it will be minus 2. If you want to calculate additive inverse of minus 8, it will be plus 8. So we have to multiply the number by minus 1. So as we said that A upon B and C upon D are negatives of each other. So here we have A upon B is equals to minus C upon D, right? That is, A upon B is negative of C upon D, or you can write C upon D as minus A upon B. That is, C upon D is negative of A by B. Now if you bring this minus A by B to LHS, it will become positive, and again it will give the same result, that is A upon B plus C upon D is equals to 0. So this is the concept of existence of negative or additive inverse. Now you can see that after adding additive inverse, we are getting additive identity. 0 is the additive identity. So you can also say that if a number is added to another rational number and we get additive identity, then that number is called inverse of that rational number. Okay, now let me give some examples and illustrate this. Let us check additive inverse of, so find additive inverse of first minus 5 upon 7, second 0, and third 1 upon 2. So for first part, additive inverse for first part, additive inverse is equals to minus of minus 5 by 7, right? I said that multiply the number with minus 1 and you will get the additive inverse, which would be 5 by 7. For second part, additive inverse equals to minus 1 into 0, which is again equals to 0. So you can note it down that 0 is the additive inverse of itself. Okay, you can note it down that 0 is the additive inverse of itself. For the third part, additive inverse equals to minus 1 into 1 by 2, which is equals to minus 1 by 2. So minus half is the additive inverse of half. So you can conclude that 0, that is this 0, is the only number. 0 is the only number, or we can say only rational number. 0 is the only rational number, comma, which is additive inverse, which is additive inverse of itself. So you can see 0 is the only rational number which is additive inverse of itself. Clear? So this was the concept of additive inverse, or you can say negative of a rational number. Now let us do some questions so that we can understand these properties better and we can realize how we can use them and we can get benefit of them in solving questions. So we have to rearrange suitably, that is using associativity, and find the sum in each of the following. So let us rearrange it. Sir, what do we mean by rearranging? See, we are saying there are two terms having same denominators, 5 by 3 and minus 8 by 3. So we can add them together so that we do not have to take LCM because they have the same denominator. Similarly, you have another two terms having same denominator, which are 11 by 2 and minus 7 upon 2. And then you can add minus 9 upon 4 to the sum. So we will have 5 minus 8, which is equals to minus 3 whole upon 3. You can directly add the numerators because numerators are same. Similarly, here you can have 11 minus 7, which is equals to 4 upon 2. And here you have minus 9 upon 4. Now let us simplify them, that is bring them to the lowest value. So cancelling out 3, which is the common factor, we will get minus 1. Cancelling out 4 by 2, we will get 2. And here we have minus 9 upon 4. So again simplifying, we will get 2 minus 1 is equals to 1, and we will have minus 9 upon 4. Now taking the LCM, because if there is nothing, there is 1, LCM would be 4. So 1 into 4 equals to 4. So here also 1 into 4. And since there we have already 4, so we can write minus 9 directly. And we will get 4 minus 9 upon 4, which is equals to minus 5 upon 4. So we were able to solve this very easily because we have used the property of associativity. And we have tried to pair up the terms having same denominator. Okay, similarly we can do another question, which is minus 4 upon 7 plus 7 upon 6 plus 2 upon 7 plus 3 plus minus 11 upon 6. So again we can rearrange them. We can add minus 4 upon 7 and 2 upon 7 together since they have same denominators. Okay, then we can add 7 upon 6 and minus 11 upon 6 because again they have same denominators, and then we can add the result to 3. So we will get minus 4 plus 2, which is equals to minus 2 upon 7 because they have the same denominator, so we can directly add the numerators. Similarly, we have 7 minus 11 equals to minus 4 upon 6. Again they have same denominators, so we can add the numerators directly, and then we will have 3. So let us first solve these two. So LCM of 7 and 6 is 42. Okay, so we are going to get 42, and we will have 7 into 6, so minus 2 into 6, minus 12. Similarly 6 into 7, so minus 4 into 7, minus 28. Here you can note one thing, which is I intentionally did not cancel out minus 4 and 6 just to show you what happens if you not cancel out. It will not affect any kind of way the answer. If you get the answer a bigger one, you can directly cancel out them in the final answer. Okay, so we have intentionally have not cancelled 2 from 4 and 6 so that we can see what effect it does on the final answer. So let us see. Okay, so 6 into 7 equals to 42, so 4 into 7 equals to 28. So minus 12 and minus 28 is equals to minus 40. And here we have 42. See, now that common factor comes in these two, so you can cancel out them here. You can write it minus 20 upon 21, or if you want you can again carry out in forward, but it will be just a waste of time. So let us cancel out the common factors, and we can write minus 20 upon 21 by cancelling out the common factor 2 and then adding it to 3. Now taking the LCM, we would get 21. So 21 into 21, so 21 into 1 is equals to 21, so we will get here minus 20. 1 into 21 is equals to 21, so we will get 3 into 21 as 63, and we will get 43 upon 21 as the final answer. So again we were able to solve this question because we know the property of associativity will help us when the denominators are same. So we paired at the same number and then we added them very quickly. So this was all about today's lecture, in which we have studied properties of rational number. Thank you for watching this lecture till end. We'll meet in the next lecture. Till then, goodbye.